Hi, welcome to the video of Wireless Network Technologies assignment, the foundation knowledge required for wireless communication. My name is Shavindra Chandrasena and my registration number is MS24909396. In this video, I will provide an overview of key concepts covered in Wireless Network Technologies module from lectures 1 to 6, focusing on the fundamental principles and technologies that enable modern wireless communication. I will discuss the OSI and the TCP/IP models, which structure network communication into different layers, making data transfer efficient and reliable. Additionally, I will explore various signal types, bandwidth calculations, and error detection techniques essential for accurate data transmission. Wireless communication is built on important techniques such as modulation, multiplexing, advanced antenna systems, so I will explain how these technologies, including beamforming and MIMO antennas, enhance the network performance and reliability. Furthermore, I will also cover various aspects of wireless communication, including network protocols, transmission methods, and security considerations. So this includes an understanding of different transmission media, both wired and wireless, the role of antennas in signal propagation, and how multiple access technologies allow efficient communication between multiple users will also be discussed. So additionally, I will talk on wireless network standards, the evolution of Wi-Fi technologies, and the impact of modern advancements such as 4G and 5G, etc. Security remains a crucial part of the wireless network, so I will also discuss encryption methods and authentication mechanisms that will help to protect the data transmission. So by the end of this video, you will gain a clear understanding of the key topics that we have covered in lectures 1 to 6 and how they will help in developing efficient and secure wireless systems. Now let's take a look at the OSI model, which is essential in understanding how the data moves across a network. So the OSI model consists of 7 layers, as you can see here. So each playing a crucial role in data communication. So let's start from the top. So the topmost layer is the application layer. So this is where the humans interact with the application that has network services. So it enables things like web browsing, email, and messaging. So for example, web browsers such as Chrome, Firefox, or email services like Gmail, Outlook, or video services such as call services such as Zoom and Skype. And then the next layer is the presentation layer. It ensures that the data is in a usable format and handles encryption and compression. So, such as like compressing a video to send over a video until it reaches the correct user, or SSL or TLS encryption for secure websites using HTTPS. And then the next layer is the session layer. So it manages sessions between applications, keeping track of open connections and communications. For example, staying logged into a website while navigating in different web pages, or like keeping a live video stream or a gaming stream. So the next layer is the transport layer. It ensures reliable data delivery using protocols such as TCP and UDP in handling error detection and retransmission. So UDP and TCP will be discussed later in this video. And the next layer is the network layer. It determines the best route for data to travel between devices, for GPS for the internet. And for example, we can say that the IP addresses are used to uniquely identify the route which the traffic need to be directed. So the next layer is the data link layer. So it structures the data into frames and ensures error-free transmission between two directly connected nodes. So for example, we can say MAC addresses in the internet and network switches. So the last layer is the physical layer. So it is the foundation of the OSI model. So it is responsible for transmitting raw bits over a physical medium like cables and wireless signals. For example, Ethernet cables, fiber optics, or Wi-Fi signals. So each layer plays a crucial part in making the communication reliable across networks. So understanding the OSI model help us to troubleshoot issues, optimize network performance. So that's about the OSI model. So let's move on to the next part, which is the communication fundamentals. So when talking about analog and digital signals, there are two ways to send data. So, analog signals are smooth, continuous waves like sound waves in music or radio broadcast. But digital signals are more like a series of on and off pulses represented by ones and zeros. So, it's just like how computers work. So, like digital signals are clean and less affected by noise, which is why they are used in modern communication systems like internet and mobile phones. So, if we talk about the modulation techniques, so modulation techniques help us to send signals over very long distances. So there are two types of two categories of modulation. So one is analog modulation, and the other one is digital modulation. So if we talk about the analog modulation, there are two types. So AM, so which is amplitude modulation, it is used in AM radio systems where the strength of the wave changes. And if we talk about the frequency modulation, it is used in FM radio systems where the frequency of the wave is changed. So if we talk about the digital modulation methods, the one is ASK, amplitude shift keying, a digital method where the signal strength changes between high and low. If we talk about FSK, frequency shift keying, it is a digital method where the signal switches between two frequencies. If we talk about PSK, so phase shift keying, it is a method where the signal phase changes to represent the data. So then if we talk about multiplexing, there are three types of multiplexing. So multiplexing allows us to send multiple signals to share the same channel to improve the efficiency. So one type is time division multiplexing. So it's like taking in turns. So each signal gets a time to send its data. And if we talk about the frequency division multiplexing, so different signals traverse at different frequencies. So it allows like a different a signal with a different frequency go at one at a time. So it is mostly worked on radio stations. So if we talk about orthogonal frequency division multiplexing, those are used in Wi-Fi and 5G. So this method splits data into smaller parts and send them at different frequencies to avoid interference. Moving on to the next topic, analog to digital conversion. So, what is analog to digital conversion? So, it is the process of transforming continuous analog signals into digital signals for processing, storage, or transmission. So, this conversion is important because this computers, smartphones, and digital devices can only process digital data. So, for example, a microphone records only voice as analog signals, but the computer has to convert it into digital signals for storage and playback. So, there are three steps in analog to digital conversion, which is known as the pulse code modulation. So the first step is sampling. So sampling is a process of measuring the amplitude of an analog signal at regular intervals. So the Nyquist theorem says that the sampling rate must at least be twice as the highest frequency as the original signal to accurately reconstruct it. And the next step is the quantization. So once a signal is sampled, each sample value must be converted into a finite set of values. So this process is called the quantization. So where each sample is rounded to the nearest predefined value. So condensations can introduce small errors because the actual sampled value may not match the nearest predefined value. So the last step is the encoding, so which is converting into binary. So after condensation, the sample values must be converted into binary format so that digital systems can store and process them easily. So each quantized value is assigned to a unique binary code which represents the signal in digital form. So that is about the analog to digital conversions. Understanding bandwidth and noise. So when talking about bandwidth and noise, what is bandwidth? So bandwidth refers to the maximum amount of data that can be transmitted over a network connection in a given time. So there are two types of bandwidth, analog bandwidth and the digital bandwidth. So analog bandwidth is the difference between the highest and the lowest frequency in a signal, and the digital bandwidth is the amount of data that can be transmitted. So how signal strength is measured? Signal strength is measured in decimals, which indicates signal gain or loss. So there is power gain and voltage gain. So power gain measures the power change in the signal, and the voltage gain measures the voltage difference between the two inputs. So those two are calculated using these two equations. So the a higher decibel value means a strong signal, while a lower or negative dB means the signal is lost or very low. So for analog signals, bandwidth is calculated using a simple equation where the highest frequency minus lowest frequency. And for digital signals, we use a formula called Shannon's capacity formula. So this formula determines the maximum data rate a channel can handle, even there is noise. So it has a little complex equation. So C stands for the maximum data capacity, and B stands for bandwidth, and S over N stands for signal to noise ratio. So higher the value means better quality. So what is noise? So noise refers to an unwanted interference that distorts a signal and reduces its quality. So there are different types of noise, such as thermal noise, which is caused by movement of electrons in a circuit, and intermodulation noise, where multiple signals mix and create interference, and also the crosstalk, where signals from one channel interferes with another channel's signals. And another one is impulse noise, like sudden spikes caused by electrical devices, lighting, or switch circuits. So that's about bandwidth and noise. We can move on to the next topic: transmission media. Transmission media refers to the path through which data is transmitted from one place to another. So it can be categorized into two types. So the guided media in wired communication. So guided media consists of physical cables that carry signals from one devices to another. It is considered more secure and stable than wireless communications. So examples could be copper cables or fiber optics, which are commonly used in Ethernet connections and telephone lines. And if we talk about unguided media, which is used in wireless communication, unguided media transmits data without physical cables using electromagnetic waves. So while this offers more flexibility, it can be affected by interferences or signal loss. So examples include radio waves, which are used in Wi-Fi and FM radio broadcasting, satellite communication, and microwaves in mobiles. Moving on to the next topic, TCP/IP model. So what is TCP/IP? So TCP/IP stands for Transmission Control Protocol and Internet Protocol. So it is a set of rules that allows computers and devices to communicate with each other over the internet. So every time you browse a website or send an email or make a video call or connect to Wi-Fi, TCP/IP is needed. So the TCP/IP is made up of four main layers, with each layer having a specific role in handling data. So the topmost layer is the application layer, where this is the where the users interact with the application to access the network devices. So it enables things like web browsing, emails, and messaging. And the next layer is the transport layer. So the transport layer controls how the data is sent between devices. So it breaks down large messages into smaller packets and ensures they reach the correct destination. So the key protocols in transport layer is the TCP, Transmission Control Protocol. So the TCP is a reliable and a connection-based protocol, which means it ensures that the data is delivered correctly and in the right order before reaching the receiver. So the other features of TCP are error checking, order delivery, slower but secure. So, which means that because of the extra steps of reliability, TCP is slower than UDP but ensures the data integrity. So where the TCP is used, so it is used in web browsing for HTTP and HTTPS, and in file downloads, which is FTP, and in emails, which is SMTP, and also in video conferencing when reliability is required. So for an example, imagine if we are downloading a file, TCP makes sure that every piece of the file gets downloaded correctly. So if there's a packet missing, the TCP will request to resend to complete the file again. So what is the other protocol? So it is UDP. So UDP is known as Used Datagram Protocol. So UDP is faster but less reliable protocol that does not check if all the data is received correctly. So if it is connectionless, it means that it does not establish a connection before sending data. So the key features of UDP are no error checking. It is really good for real-time applications, which means that it is used where speed is more important than accuracy, and it has an unordered way of delivery. So where is UDP is used? It is used in live video streaming. Such as YouTube, Netflix, and Twitch, and in online gaming, when low latency is required, in voice over IP calls such as Skype, Zoom calls, etc. So, for an example, if you are watching a live football match online, so if some data packets are lost, the UDP doesn't stop the stream. It requests missing packets. It does not request missing packets, but it just keeps on playing to avoid buffering. So, if we talk about the network layer. So this is the layer which is responsible for addressing and routing data. So it reaches the correct destination. So the key function of the internet layer is like assigning the IP addresses to the devices and uses routers to direct the data across the networks and determines the best path for data transmission. So the main protocol of network layer is the internet protocol, which identify devices with unique IP addresses and move data between networks. So if you take an example, when you send an email, IP ensures that it reaches the correct recipient by assigning the IP address to the sender and the receiver. And then let's look at the other layer, so which is the data link layer. So this is the layer that physically transmit data over wired or wireless networks. So function of the data link layer is to convert data into signals such as electrical, optical or radio waves. And also it handles hardware components like network cables, Wi-Fi and fiber optics. And also uses media access control addresses to identify devices within a local network. So for an example, when you connect to a Wi-Fi, the network access layer transmits the data using the radio waves. So the data link layer is divided into two sub-layers, the LLC, logical link control, and the MAC, media access control. So the logical link control is responsible, and it is the upper sub-layer of the data link layer of ensuring the data is transmitted smoothly without any errors. So the functions are it detects errors, it controls the flow, and it also controls protocol multiplexing, and also it controls the acknowledgements. So for an example, when we are sending a file over the Wi-Fi, LLC ensures that the data packets arrive correctly in the right sequences. So the other component is the media access control, MAC. So MAC is the lower sublayer of the data link layer. It controls how devices share and access the network to prevent data collisions. So the functions of MAC is that it frames encapsulation, which wraps data into frames for transmission, and also it is responsible for addressing. So it uses a unique address called MAC addresses to identify the devices uniquely, and also it prevents collision. So it uses methods like CSMA-CD for wired Ethernet and CSMA-CA for Wi-Fi to avoid two devices sending the data at the same time. So for an example, every network devices like phone, laptop, or router has a unique MAC address. So when you connect to a Wi-Fi, the MAC sublayer ensures that the data is sent to the correct device. So that's all about the layers. So let's look at the error detection and control in the data link layer. So what is data detection and why it is important? So data transmission is not always perfect. Sometimes noise interference or hardware issues can cause errors in data. So when errors happen, the received message does not match the original message, leading a corrupt or missing data. So there are three types of errors. The single bit error. So that is happens when one single bit of a data packet is flipped or changed, and the other error is a multiple bit error, so when one or more bit changes during transmission, and the other error is the burst error where the sequence of bits is incorrectly flipped at once. So for an example, if you're sending a message called hello, HELLO. So if a burst error happens, the hello message could go as HEMMO. Error detection methods. Error detection methods ensure that the data is accurate and reliable. So the data link layers use error detection techniques such as parity checks. So it is a simple error detection method where a parity bit is added to check whether if the number of ones are odd or even. And the other one is a checksum. So it is a mathematical addition. So if the data is broken into blocks, it checks and it adds together to see whether if the sending data is equals to the received data, and the other one is the CRC, cyclic redundancy check. So it uses a mathematical polynomial division to generate a specific code to understand whether there is an error in the sent signal. When we talk about antennas, an antenna is a device that converts electrical signals into radio waves and vice versa. So it enables wireless communications. So the antenna theory is known as converting electrical signals into radio waves. So when it comes to antennas, they are based on several key factors. So the first one is polarization. So it is the orientation of radio waves, which can be vertical, horizontal, or circular, so affecting how well the signals are received. And the other one is impedance force. So it ensures efficiently the energy is transferred between the antenna and the transmitter or the receiver. And if we talk about bandwidth, it determines the range of frequencies an antenna can operate on. A wider bandwidth supports more data transmission. And if we talk about the radiation pattern, so it describes how an antenna spreads energy, either in a narrow beam in one direction or in all direction, which is also known as omnidirectional. So if we talk about the resonance point, so it is the frequency at which the antenna operates most efficiently, so which reduces signal loss. Also, if we look into advanced antenna technologies, antenna beamforming is one advanced technology. So these are used in 5G and Wi-Fi to focus signal towards specific users instead of broadcasting in all directions, which improves speed and efficiency. And one other advanced antenna technology is MIMO antennas, multiple input, multiple output antennas. So these are found in 4G, 5G, and Wi-Fi, allowing multiple signal to be sent and received at the same time for fast and more stable connections. So if you talk about smart antennas, so these antennas are like set to automatically adjust their radiation pattern to minimize the interference and improve signal strength. So these can be found in satellite communication. So if we talk about data transmission methods, so wireless systems use different methods to send and receive data. So there are two main types that we talk about. So the first one is the HDD, half duplex division. So this is like communication. In this, communication happens in one direction at a time, like a walkie-talkie. And if we talk about the other data transmission method, we can say FDD, so which is frequency division duplex. So it uses separate frequencies for simultaneous transmission and reception, like in cellular networks. So if we move forward, we get multiple we have learned about multiple access technologies. So multiple access technologies methods means that allows multiple users to share the same communication medium without any interference. So these technologies are essential for networks like cellular communication, Wi-Fi, or satellite systems. So there are three types of multiple access technologies. So the first one is TDMA, time division multiple access. So how it works is that each user gets a time slot to send and receive data, preventing interference. And if you talk about FDMA, so frequency division multiple access, how it works is that it divides the communication channel into separate frequency bands for each user. So these are used in FM radio systems. So if we talk about CDMA, code division multiple access, how it works is that it assigns a unique code to each user, allowing multiple users to share the same frequency simultaneously. So these can be found in 3G networks and GPS systems for secure and efficient communication. So when multiple devices try to send data over shared network, collisions can happen. So to avoid these collisions, two methods are used. So the first one is CSMACD, carrier sense multiple access with collision detection. So these are mostly used in Ethernet wired networks. So how it works is that the devices check whether the if the communication channel is free before sending the data. So if two devices send the data at the same time, a collision is detected and both devices stop. So they wait a random amount of time before trying again. So the other method regarding collision avoidance is CSMACA. So carrier sends multiple access with collision avoidance. So these are used in Wi-Fi wireless networks. So how it works is that instead of detecting collisions, the device first sends a request to transmit, which is known as RTS. So if the network is free, they get a clear to send response, which is known as CTS, before sending the data. So this survive the collision rather fixing them after they happen. Wired LANs and wireless LANs. So what is a LAN? So a local area networks connect devices within a small area like a school or office. So LANs allow computers and phones and other devices to communicate and share resources. So when if you talk about wired LANs, so it they uses physical cables to connect to devices for fast and stable communications. So for an example, a desktop PC connected to a router using an Ethernet cable. So advantages of wired LANs is that it has faster speeds and it is more secure, and it has no interference from other devices. So if you talk about wireless LANs, so it uses radio waves instead of cables, allowing the devices to connect to physical connections. So it is also common in homes, cafes, airports, and businesses. So for an example, a laptop connected to a Wi-Fi from a router. So the advantages of wireless LANs are it provides mobility. So the user can move around and stay connected easily. So no cables are needed. So it makes a easier setup, and it also supports multiple devices at once. So but the disadvantages are like it is slower than wired LANs due to interference and more vulnerable to hacking. So if we talk about wireless LAN access methods, so Wi-Fi networks use different methods to organize communication between devices. So the first one is basic service set, BSS. So a basic service set consists of a single Wi-Fi access point, such as a router that provides connectivity to multiple devices within a limited area. So each device in the network communicates only through access point, not directly through other devices. So it is simple to set up and manage, and it works well in small areas with few devices. But it could be limited coverage and can have network traffic. So if you talk about another access method is that ESS, extended service set. So it is a network with multiple access points connected to each together, which create a larger Wi-Fi coverage area. So all APs are linked to the same wired network and share the same SSID, so Wi-Fi network name. So it allows seamless roaming. So uh, the connection is easy. So it can be also like improved, and it is scalable. The network can be made big, but sometimes it can be complex to set up, and it also requires a centralized control. So if you talk about point coordination protocol, so it is a media access control MAC protocol used in Wi-Fi networks to manage traffic and avoid collisions. So it is a part of IEEE standards, and it helps in handling multiple devices trying to send data at the same time. So it reduces collisions and interference, leading to more stable Wi-Fi connections, and it also ensures fair access to all devices. So sometimes there can be high latency, and also it is less commonly used in homes and Wi-Fi networks. So if we look into more about wireless LANs, so there are challenges in wireless networks. So one challenge that we find is the hidden station problem. So this occurs when two devices cannot detect each other's transmission due to physical obstructions or distance. So even though they are within the range of the same Wi-Fi access point, it is hard to detect. So since these devices don't know about each other, collisions may happen, causing slowdowns or retransmissions. So the solution is like to use clear to send request and clear to and request to send request mechanism in CSMA. So the other problem is the terminal exposure problem. This happens when a device stops transmitting unnecessarily. So even though it wouldn't have caused interference. So this is a waste of network band, and as the device could have continued sending data. So using a modern Wi-Fi protocol could solve this problem by managing the network access. So if we look into the key IEEE Wi-Fi standards, the Wi-Fi have evolved over the years, improving speed, efficiency, and security. So as you can see here are the main major IEEE Wi-Fi standards. So this being the first Wi-Fi standard supporting speeds up to 2 Mbps. So this was introduced in 1997, and the latest is the Wi-Fi 7, which was introduced in 2024, and this has very high speeds and lower latency. Then, if you look at the Wi-Fi security standards, with wireless network, security is crucial to protect data and prevent unauthorized access. For this, protocols must be used. So, WEP, Wired Equivalent Privacy, was the first protocol that was designed to provide encryptions for wireless networks using IEEE standards. It used the RC4 cipher with a shared secret key for encryption, and it also uses a user-defined password. But this is vulnerable because it can be predictable and easy to crack. So the next one which was introduced was the WPA, Wi-Fi Protected Access. It is a protocol developed to improve the weakness of the WEP. So WPA has a strong encryption and an improved authentication mechanism. It uses a temporal key integrity protocol, TKIP, which generates a new encryption keys for each data packet. So the next one which was introduced was the WPA2. It is a little advanced than WEP and WPA because of their vulnerabilities. So it uses the standard advanced encryption method, which is known as AES for stronger encryption, and it uses a counter mode cipher block chaining message authentication protocol to improve data integrity and confidentiality. So then the latest one which was introduced was the WPA3, the latest Wi-Fi security protocol, which will improve the weakness of WPA2 against the brute force and dictionary attacks. So it introduces simultaneous authentication of equals, so SAE, replacing the pre-shared key method. So this is very resistant to password guessing attacks. So that's all about wireless LAN problems and protocols. So finally, in this video, we have discussed the key topics from the wireless network technologies module, covering concepts from lectures 1 to 6. So we explored the OSI model, the differences between analog and digital signals, the importance of modulation and multiplexing in wireless communications. We also covered antenna systems, including beamforming and MIMO, and examined multiple access technologies. And additionally, we discuss key network access methods, challenges like hidden station problems and terminal exposure, and the evolution of wireless communication standards. These concepts helps in understanding how the data is transmitted efficiently across the wireless network. So these topics provide a solid foundation in wireless network technologies, helping us to understand how the modern communication systems operate. So thank you for watching.